This, let's assume, is the cube root of 1 plus x. And let's assume that this is a equals 0. And the tangent line here is 1 plus x over 3. And you know how we determine that, right? Right?
Yeah.
Okay. So now we are asked to find the cube root of 9.95. I can punch it in the calculator and I'm done. But no, they're asking us to use the line now to see that this is a very good approximation of the actual number. And we have the actual number. The actual number of 0.95 raised to 1/3 is 0.98304 blah, blah, blah. That we have. But now they said, forget about this. Forget about this. I want you to use the line to approximate 0.95, the cube root of 0.95. But because I have this function, by comparison, or by setting them equal to each other, I have to find x. They're not giving us x. But when I set these two equal to each other, I realize that x must be 5, negative 0.05. So this is the x that is plugged in here. So the cube root of 0.95 is approximately 1 minus 0.05 over 3. And this, when we calculated it, we got 0.983333, which is extremely close. So if you want to, you run out of power, or the calculator doesn't have power, or you don't have batteries, the cube root of 1 plus x, or the cube root of 0.95, you can easily approximate it with this line. It's not going to be exact, but look, you have 3 digits approximation. It's more than you need. So in order to approximate the cube root of 95, I use the line, not the function. Why? Because the line approximates the function near 0. This particular line. For this point, I have to determine another line, not this one. Because I have to determine it where a is whatever. I'm not sure whether did I answer your question, or not sure yet. You may be talking to me, but you're muted. I'm not sure. Did you lose me?
Sorry, I had to take a call.
No worries.
What did you say?
Did you have any questions? Is this clear now?
Yes.
Perfect.
Professor, I have a question.
Yes?
I'm not sure where it's from. I just have on my notebook that I was struggling with it.
That's fine.
It's f of x equals 4 raised to the power of 2 square root of x.
F of x equals 4
raised to the power of 2 square root of x.
Like this?
Yes.
Okay, so we want to differentiate this?
Yeah.
Okay, perfect. So remember, if we have e to a function prime, we have e to the function times the function prime. I should always write natural log e. I don't. Why?
Because it's 1.
Exactly. That's all you need to remember. So let's cover it now, because this is not e. So a natural log 4 will come into play. So when I differentiate a base to a function, prime is the base to the function, to whatever, it was to the square root of x, times to the square root of x prime, but times natural log 4, because it's not 1. So then finally I have 4 raised to 2 the square root of x. I know how to differentiate that. It's 2 over 2 the square root of x, and I will simplify, times natural log 4. So finally I have 4 raised to 2 the square root of x times natural log 4, everything over the square root of x.
Okay, thank you.
Is that better?
Yeah.
Okay, always, I'm not saying that you should do that necessarily, but just imagine. So if you have a function, e to a function, then this is clear, natural log e is 1. But if you have anything else, always remember to multiply by natural log 4 in this case, or natural log a. Good, very good questions. Anything else? Can I choose now? Is it my turn? Do you have anything else you would like to ask? Anything? Okay, so then if it's my turn, I'm going to look at y equals theta squared. You can always stop me with any other question. And I want to find the differential of this function. Good, so can anyone get us started? Any question or any suggestion, anything?
Would we start with the product rule?
Correct. But can anyone give us, before we do that? Perfect, of course, it's a product rule. This is function number 1 and this is function number 2, no question. So can anyone give us the differential, the formula for the differential of y? And I'll write it here.
dy over dx.
dy over dx is y prime. Y prime equals dy over dx. We don't want y prime, we want the differential. This is the derivative.
Well, maybe like dy is equal to 2 theta.
Just the formula first. Just the formula first. So let's call this f of theta.
Would it be f of theta times dx? Or f of theta prime?
Very good. And I cannot use, but excellent, perfect, Katie, thank you. I cannot use dx because the variable is theta, but I have to use d theta. Excellent, this is indeed the differential. Thank you very much. This is the differential of y, or f of theta. Excellent, good. So now let's start with doing this, so finding f prime of theta and then putting it in here. So first we can start separately with f prime, but then we have to put it in this formula. Good. So we identify. Yes?
What's that last thing? D theta?
Yes?
And what does that mean?
It's dx, but since the variable is theta, I have to use d theta.
Okay, thank you.
Same thing, yep. I have to stick with the variable. Good. So f prime of theta, of course, you already told me, is 2 theta times sine 2 theta plus theta squared times cosine 2 theta and times 2. So sine prime is cosine times the inner function prime, which is 2. So I'm going to just rearrange it a little bit. 2 theta sine 2 theta plus 2 theta squared cosine 2 theta. But this is not the differential. Now we can write a differential. All this has to be in parentheses. If you do not write this in parentheses times d theta, then that would be wrong. So this is 2 theta sine 2 theta plus 2 theta squared cosine 2 theta. And this is the differential of the function. And you can say, why are you making such a big deal out of this? Because you'll see in chapter 5 why. The differential is a big deal.
Is the differential just the same thing as the derivative, except you multiply by like dx, or in this
Correct.
case d theta?
Correct.
Okay.
Absolutely. Yes. And you'll see in chapter 5 why that is so important. Okay. Did you find anything else from me, or I continue choosing?
On the test for this,
Yes?
it would specifically say find the differential.
Absolutely. Absolutely.
Okay.
It will specifically say find the differential of the function. Yes. Promise. Okay. Do you have anything else, or can I choose? Okay. You can stop me anytime. Okay, I guess is my we are given f of x, which is a function g of natural log x. And they are asking us to find f prime in terms of g prime. So find f prime. So this is not the differential. We're only asked to find the derivative. Okay, so can anyone tell us how to write? And remember, g is a function. G is a function. Can anyone tell us how to write this?
That says G times ln x, right?
No,
What does that say?
g has to have a function. So if a variable, if I don't write g of x, and I write g of natural log x, then we know that this is not a product, right? G is not times x, and g is not times this. So it's g of natural log x.
So do you want like a g prime of ln x?
So g prime of natural log x times
ln x prime,
which is
1 over x.
That's it. Excellent. Okay. Let's look at this limit. Limit as x approaches 0, sine 3x times sine 5x divided by x squared. My apologies if we have done this before. I don't remember exactly. Okay, so this is a limit, and we have to plug it in, and luckily it's 0 over 0. Yes, we already discussed L'Hopital's rule. In the 0 over 0 or infinity over infinity, we can differentiate the top and the bottom. There is an easier way for this, because differentiating top and bottom will not be very easy. It's a product. So we will have sine, cosine, and it gets complicated. So, but we know something else, that we can manipulate the function. By manipulate the function, I mean presenting the function in a different way. That's what I mean, not changing the function, right? So I know that limit as x approaches 0, I can write it as sine 3x over x, and then sine 5x over x. And I also know that when x approaches 0, Also 3x approaches 0 and 5x approaches 0 because I can multiply both sides here by 3 or 5. It doesn't matter. But if I don't, I'm missing something here to draw a conclusion. What am I missing here? And what am I missing here?
Turn the 5.
Yes, but I cannot simply say, okay, I'm going to put a 3 in here without putting a 3 here because 3 over 3 is 1. I cannot put a 5 in here without putting a 5 here. I'm allowed to multiply top and bottom by 3. That doesn't change the problem or the function. I'm allowed to multiply top and bottom by 5 because this is 1. But now I know that this piece approaches and this piece approaches as long as 3x and 5x approach 0. And these are all the same.
One.
Yes. So therefore, the limit must be
15.
That's it. That's it.
That
Awesome.
you're counting the 3 and the 5 as the 1.
I do that a lot myself. So
I gotta ask, what is this called again?
it's not called anything. It's we know that there is a property that when all these three are the same and they approach 0, the answer is 1. And also the reverse, multiplicative inverse, this over sign. We know that as a result. So we are using this famous result. Okay. Now, for example, any questions on this? For example, on something like this, limit as theta approaches 0 from cosine theta minus 1 over 2 theta squared. This cosine 0 is 1, 1 minus 1 is 0, the denominator is 0 as well. So on this, you can use L'Hopital's rule. Remember, L'Hopital's rule says that if we have a limit, and we have a ratio, and we have 0 over 0 or infinity over infinity, then and only then we can differentiate the top and differentiate the denominator. We never do that. The quotient rule or the ratio rule does not allow us to do that. But when we have a limit, when the limit is applied to a ratio, and we have 0 over 0 initially or infinity over infinity, we will differentiate the top and differentiate the denominator. And now I know where this is going. As long as theta approaches 0. Where is this going?
Zero. Oh. 1.
Right? I have sine theta over theta when theta approaches 0, so the answer is 1. So what is the final answer then?
Negative 1/4.
That's it. Negative 1/4. Good. Okay.
So what would a question like this be asking us to do? Would it be just to evaluate the limit?
Yes. Just find the limit. Mm-hmm. What about I have y equals sine x plus cosine x. I'm given a point, 0, 1. Find the equation of the tangent line to the curve at the given point. So I have y minus 1 equals the slope times x minus 0. I shouldn't even write the 0, but okay. Or because it's the y-intercept, I can write y equals mx plus b, where b is 1. That's even better. So mx plus 1. Okay, so I need to find the slope. I will differentiate y prime equals cosine x minus sine x. And when I plug in 0, I get cosine 0 is 1, this is 0, so the answer is 1. So this is 1. So y equals x plus 1 is the equation of the tangent